I'm going to find increasing or decreasing. I care about when f prime is greater than 0 or less than 0. So let's go ahead and get f prime going. Looking at -1/2 x to the -3/2 plus 1/3 times 3/2 times x to the 1/2 power. Now they may look gross, but we can do a couple things. I personally would choose to factor. So my 3's over here are going to cancel, which means I can for sure pull out a 1/2. And then I'm going to do a weird factoring that once upon a time in your life you probably did. But I'm going to grab the smaller power of x, meaning the x to the -3/2. And when I factor that out, from the first piece, I'm going to be left with -1. And from the second piece, I'm going to be left with x squared. Wait, yes, I'm going to be left with x squared. So if you're sitting there scratching your head, really? How? Where? Why the x squared? When we factor stuff, it means that if we distribute this back in, we should get what we started with. So if I think about distributing this back in, x to the -3/2, when that gets distributed in and multiplied by x squared, I'd add those exponents. -3/2 plus 2 should give me a positive 1/2 back. Not like, yeah, I totally figured that on my own, but now that you've seen me do it, how are we feeling about that? It's not the only option. The other option would be to write things as fractions and get common denominators and stuff. That works too. So I am going to go ahead and rewrite that a little bit. So -1 plus x squared means I'm going to write that as x squared minus 1 because it works better in my brain. Because that was a negative exponent of 3/2, you might want to write that as 2x and then 3/2 down here at the bottom. You don't have to write it that way, but you could. So I know that for sure the top is going to factor. Can I have x plus 1 times x minus 1? And I've got 2 over x to the 3/2. This is really gross. I maybe gave us something too gross, but I looked at those web work problems and you had a really gross one too. So yeah, so as an alternative path, if you didn't like the factoring thing, oh, we got lots of questions. People are asking, we're like lots of stuff, lots of questions. Cool. I like questions. I feel like I didn't leave myself enough space because I wrote all this stuff down over here. So I'm actually going to give myself a totally clean piece of paper. And slow motion on that because I think there was a question on the derivative itself. So I've got x to the -1/2 plus 1/3 x to the 3/2. So if I back up and just talk about that derivative, I'm bringing down the exponent and subtracting 1 from the exponent. But -1/2 minus 1 is going to give me -3/2. I've got that 1/3 times, I'm bringing down the exponent of 3/2 and subtracting 1 from the exponent, I'd be at x to the 1/2. If you are not feeling great about fractions, if decimals work better in your head, you're always welcome to switch stuff around to decimals. But I will say, these are pretty common fractions to have to deal with. So you can kind of get to see the pattern of things. If I have -1/2 and I add 1, I'm adding 2 halves. So I'm going to get to +1/2. If I have +1/2 and I add 1, I'm adding 2 halves. So I get to 3 halves. So we kind of have this cycle. If I have 3 halves and I add 1, I'm at 5 halves. And obviously here I'm adding, but this way I could be subtracting. So anyway, common fraction-y things that are going to show up over and over and over again. Well, if I clean this up a little bit, that means I've got -1/2 x to the -3 halves. 1/3 times 3 halves would just be a 1/2. And now personally, I would choose to factor this. Because basically anytime I'm setting stuff equal to 0, I'm hoping things factor. So I would pull out the 1/2. And if you want to just like do that first, you can definitely just do that first. Pull out the 1/2. But I'm also going to say these both have terms with x's in them. And I'm going to choose the smaller one. 3 halves. And I know 3 halves, like as a number is bigger than 1/2, but because it's negative, I'm talking about the one that's furthest to the left on the number line. So if I pull out 1/2 and x to the -3 halves, then in this first term, the only thing I'm left with is the -1. And when I pull all of it out over here, that's where the weirdness happens. So my 1/2 is definitely gone. These powers of x don't match up. But I'm thinking about this as like x to the something. And when I distribute this back in, I need that x to the -3 halves plus something would give me the 1/2 back that we started with. And the something that I need is 4 halves. So I'm looking at 0 is equal to 1/2 x to the -3 halves times -1 plus x squared. And then you can decide how you want to write that. It is totally fine to leave that alone. It would be totally fine to write that as x to the -3 halves and then write this as an x minus 1, x plus 1. However you want to deal with it, for sure. I'm ready to think about my number line. Now, part of the reason that I chose this question is that when we go to think about a number line, this would suggest to me that I have 3 numbers to put on that number line. -1, 0, and +1. But that's actually not true. I didn't explicitly state it about my function. But that 1/2 exponent, or heck, even that 3 halves exponent over there, what kind of numbers can I take the square root of? Or rather, what can I not take the square root of? Right, which means none of this is in the domain of the function, and none of it matters when we start talking about our derivatives. And there are some web work problems, not where you necessarily have to know what the domain is, but where web work has restricted our domain and told us to only consider the function on a certain interval. Since all of that stuff is not in the domain of the function, it makes it a little bit easier to plug numbers in. We're not doing like 100 things, right? So for sure, I can choose test points of like 1/2 and 2. Why not? Yeah, so -1 is not in the domain. 0 is also not in the domain, fun fact. But if I go back up to the original function, something to the 1/2 power is the same as taking the square root. So that x to the -1/2 power is the same as 1 over the square root of x. And I can't plug negative numbers into the square root. So it's not in the domain, so we're not going to consider any of it. So if I plug in test points, if I plug in 2, that's positive. That's also positive. So is this. Now remember that I don't really need to know the value here. I just need to know if it's positive or negative. But that square root piece, if I'm taking the square root of it, it has to be positive. Square roots are only going to spit out positive numbers. So I'm good. I got a positive times a positive times a positive. This function is definitely increasing. If I plug in x equals 1/2, 1/2 plus 1 is positive. 1/2 minus 1 is negative. And just like with the other number, whatever I plug in here, I'm about to take the square root of it. I'm going to get a positive number there. So I'm going to have a positive times a negative times a positive. This will be negative. This is decreasing. So if I were to write the intervals where it's increasing and decreasing, I have to take into account that domain piece. So I'm, oh yeah.
X to the -3 1 over 2 times the square root of x to the -3rd. So like, I don't understand how
Oh yeah, good question. So, yeah, the x to the -3/2. I'll come off over here. I'll just write it here. So x to the -3/2 is like saying I have 1 over the square root of x cubed. Alternately, that's the same as saying I have 1 over the square root of x cubed. But no matter way I want to play it, if I put in 1/2 and I cube that, it's positive. When I take the square root of that, it's still positive. Or if I take the square root of 1/2, I don't know what that is, but it's some positive number. And then when I cube that, it's still positive. It is confusing because of the negative exponent. Our brain wants to do something with that negative, but the negative just means it's down there in the denominator. Yeah. By the way, this is by far like the messiest thing I've seen on web work. But I figured we might as well do the messy one, right? Okay, so I would say that this is increasing from 1 to infinity. It's decreasing from 0 to 1. What was the next thing I asked us for? Relative maxes and mins. So I really only have one critical number here. Well, actually 2. At 0, it's undefined because that x to the -3/2 means that really it's down here in the denominator. So 0 is undefined. It's not going to be a place where we're a relative max or a relative min, but it would be a place where the function was undefined. But in terms of the relative max and relative min, I know that I've got a relative minimum happening when x is equal to 1 because I was going down and then I'm going back up. So when x is equal to 1, f of 1 would look like 1 plus 1/3. 1 raised to any number is equal to 1, so I don't have to do a lot of math there. So 1 plus 1/3 would be 4/3. So I would say that I have a relative min at 1,4/3. I could also say that the relative minimum is 4/3, depending on how the question is phrased. I think the next part, we were going to figure out concavity. Oh, sorry. And then the next part, we were going to figure out concavity, which means we're going to need to take a second derivative. We've got choices of which version of our derivative to use to find the second derivative, but I would actually go all the way back up to the not factored version. And I would think about starting back up with my f prime being -1/2 x to the -3/2 plus 1/2 x to the 1/2. Now, the reason I'm going back all the way to this one is this version doesn't require a product rule. So if I take a second derivative here, -1/2 times -3/2 would give me a +3/4. -3/2 minus 1 is -5/2. A 1/2 times another 1/2 would be a 1/4. And when I subtract 1 from that exponent, I'll be at -1/2. And then I'm going to do the same kind of factoring that I did on the previous problem. I'm going to factor out that, if I set that equal to 0, I'm going to factor out the 1/4 and x to the -5/2. So from my first term, I'm left with a 3. And from the second term, I'm left with an x squared again. Because that 2 is really 4/2. So -5/2 plus a 4/2 would give me the -1/2 back. Is that your question? No. I thought this was, okay. Sorry. Yeah, so if I were to distribute this back out, that x to the -5/2 times x squared, if that's squared, if I think about that as 4/2, got -5/2 plus 4/2 to give me the -1/2. So thinking about like what would go on my number line here, I've got that x equals 0, but this one gives me nothing. Because if I tried to set 3 plus x squared equal to 0, that would mean that x squared was equal to -3, and that can't happen. Which means my number line would really only have a 0 on it. And we don't think about anything on that side of it because it's not in my domain of the function. So I already know that there are no inflection points. But we can think about the concavity here. And in terms of concavity, if I pick anything at all to plug in, it better be positive. So I would say in answer to part C that we're concave up from 0 to infinity. And we're concave down nowhere. And I have no inflection points.
Second part of that function didn't work because you can't take the root of it.
Yeah. Yep. Can't take the root of a negative, so we got stuck here. nothing comes out of that 3 plus x squared. We just have 3 minutes left. Should we try to graph this or not worry about that? Yeah. I got one head nod of trying to graph this. So let's just think. I know that 1/4 is a minimum on this curve. And I know that it's always concave up. And I know that if we tried to plug in 0, we actually have a vertical asymptote because from the original function, this looks like a 1 over the square root of x. So if I kind of put all those things together, I've got this vertical asymptote here. I know that we found a minimum at 1,4. I have to be concave up on both sides. I got to be concave up everywhere. And I only had one relative minimum. So whatever else this thing's doing, it's, you know, not doing anything super crazy exciting.